Large temperature difference, 50 degrees Celsius, 100 degrees Celsius, higher temperature to a region of lower temperature. It is some quantity referred with respect to distance that has to be transferred from one phase to another. Is a process, a method, a mode. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. My previous class, I discussed a very important consequence of specific heat, what we call as anomalous expansion. And we also understood how anomalous expansion of water supports aquatic life during acute winter, chill days. Today, continuing my discussion, I will try to explain the modes of heat transfer. So my topic of discussion in today's class is something called as modes of heat transfer. Probably a topic which you have already studied in your lower classes, but we will add wings and tails to this topic and understand it in a more aggravated way. So, modes of heat transfer. Here, the word mode refers to ways, different probable ways of transferring heat from one body to another. Different probable methods of transferring heat from one region to another. ಒಂದು ಬಾಡಿಯಿಂದ ಇನ್ನೊಂದು ಬಾಡಿಗೆ ಅಥವಾ ಒಂದು ರೀಜನ್ ಇಂದ ಇನ್ನೊಂದು ರೀಜನ್ಗೆ ಯಾವ ತರದಲ್ಲಿ ಹೀಟ್ ಅನ್ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಬಹುದು ಅದನ್ನೇ ನಾವು ಮೋಡ್ಸ್ ಆಫ್ ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಿ ಸೇ there are three modes of transfer of heat from one body to another, from one place to another. And these three modes or these three ways are conduction, convection, and radiation of heat. So the three probable ways, the three different ways of transferring heat from one body to another is conduction, convection, and radiation. ನಿಮ್ಮ ಹೈಸ್ಕೂಲಲ್ಲಿ ಏನು ಓದಿರ್ತೀರಾ ಅದನ್ನೇ ಸ್ವಲ್ಪ ಆಗ್ರಿವೇಟೆಡ್ ಆಗಿ ಹೈಲೈಟೆಡ್ ಆಗಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಕಂಡಕ್ಷನ್, ಕನ್ವೆಕ್ಷನ್ and radiation. Now, in my today's session, my complete discussion will refer to the first method of transfer of heat. The first mode of transfer of heat, what we call as conduction of heat. So I will be referring thoroughly to something called conduction of heat. Dear students, the process of transfer of heat in solids, very important keyword to understand conduction. The process of transfer of heat in solids. This is an efficient way of transferring heat in solids from a region of, as we have studied earlier, higher temperature to a region of lower temperature. Now first ಹೇಳಿದಿವಲ್ವಾ, heat always flows from a region of higher temperature to a region of lower temperature. Direction in heat flow though, from a hot body to a cold body. But this is very, very important. Without the actual motion of the particles, please to refer that statement. Without the actual motion of particles is called conduction. So I repeat, students, conduction is a process, a method, a mode of transfer of heat in solids. Heat transfer taking place in solids is due to conduction. From where? From a region of higher temperature to a region of lower temperature. How? Without the actual motion of the particles. Now let us analyze how this phenomenon actually happens. So this is the solid I consider. A refers to the hotter end of the solid, which is maintained at a temperature θ1. B refers to the colder end of the solid, which is maintained at a temperature θ2. So A, hotter end, which is maintained at a temperature θ1. B, colder end, which is maintained at a temperature θ2. And these are the particles of the system. Now when heat is supplied to the solid, what happens? Let me take this example. There are 20 students in a class. ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ಎಷ್ಟು ಜನ ಇದ್ದಾರೆ? 20 students. 1, 2, 3, 4, 5, 6. Like that, the last person is the 20th student. I take a book give it to the first student, ask him to transfer that book to the 20th student. ಒಂದು ಬುಕ್ಕನ್ನು ತೆಗೆದುಕೊಂಡು ಫಸ್ಟ್ ಸ್ಟೂಡೆಂಟಿಗೆ ಕೊಟ್ಟು ಅದನ್ನ 20th ಸ್ಟೂಡೆಂಟ್ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ತೇನೆ. It doesn't require for the first student to stand up, walk and give the book to the 20th student. He can simply pass the book through the others and see that the book reaches the 20th student. Alva? ಆ ಮೊದಲನೇ ಸ್ಟೂಡೆಂಟ್ ಎದ್ದು ನಡ್ಕೊಂಡು ಹೋಗಿ ಆ 20th ಸ್ಟೂಡೆಂಟಿಗೆ ಬುಕ್ ಕೊಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಅವನು ಸುಮ್ಮನೆ ಉಳಿದವ್ರ ಹತ್ರ ಬುಕ್ ಪಾಸ್ ಮಾಡಿಸಿ 20ನೇ ಸ್ಟೂಡೆಂಟ್ಗೆ ತಲುಪೋ ಹಾಗೆ ನೋಡಿದ್ರೆ ಸಾಕು. Exactly. This is how heat is transferred in solids. Simply, there is transfer of heat energy without actual motion of particles. So when heat is supplied to the solid, the particles, I say this is the first particle present near the hotter end. Now it will simply start vibrating about its mean position. ಅದು ಎಲ್ಲಿದೆ ಅಲ್ಲೇ ವೈಬ್ರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಶುರುವಾಗುತ್ತೆ. Exactly like harmonic oscillators. You can consider each particle to be a small bob of the pendulum. Simple pendulum ನೋಡಿರ್ತೀರಲ್ಲ, metal bob. Each particle behaves as a small bob of the pendulum. So this particle simply vibrates about its mean position, but heat energy is transferred to the second particle. So this is the second particle here. This again starts vibrating about its mean position. Heat energy is given to the third particle, fourth particle, fifth particle. So very clearly you see here, the particles of the solid do not move from one place to another. Wherever they are, they exhibit vibrations. They vibrate about their mean position. Only energy is transferred, heat energy is transferred from the hotter end to the colder end, and this is what is called conduction of heat. Therefore, very clearly we say it is the process of conduction of heat in solids. How? From a region of higher temperature to a region of lower temperature, exclusively important without the actual motion of the particles. And this is what we understand as the phenomenon of, yes, conduction of heat. Now we study something called temperature gradient. Gradient is a term which is always function of distance. When we talk about gradient, it is some quantity referred with respect to distance. Now, as heat flows from the hotter end to the colder end of a solid, temperature gradually decreases. Andre, when heat flows from the hotter end to the colder end, we say there is a temperature difference between the two ends of the solid. And the ratio of temperature difference between any 2 points of a solid to the distance between them is called temperature gradient. You will observe madidre, x is the distance between the points A and B. Hotter end and colder end, the distance between them is x. And I say the temperature difference is theta 2 minus theta 1. This is simply difference. So, if I speak about delta, temperature gradient, I say delta is temperature gradient. It is a ratio. Ratio of what? Theta 2 minus theta 1, which is the temperature difference divided by x. What is x? Distance between those 2 points. This ratio itself is called temperature gradient. Theta 2 minus theta 1 by x. And the SI unit, this is temperature, some type of temperature, Kelvin divided by distance. So Kelvin per meter will give me the SI unit. Now, this is a very classical concept, always asked for 3 marks in your examination, and most of the problems, numericals in this chapter is based on the topic of thermal conductivity, or we also call it as heat conductivity, flow of heat. So the topic that I will be discussing now is something called thermal conductivity. Fine. I'll consider a rectangular metal box. One the metal box, rectangle shape nallide. ಅದಕ್ಕೋಸ್ಕರ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಮೆಟಲ್ ಬ್ಲಾಕ್ ಅಂತ ಕರೆದೆ. ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾ ಎ. ಸೊ ಎ is the cross sectional area of the block, and D is the thickness of the block. A refers to the cross-sectional area. D refers to the thickness. One face of the block is maintained at temperature theta 1, and the other face is maintained at a temperature theta 2. Now Q is the amount of heat that has to flow or that has to be transferred from one phase to another. So A enagide cross-sectional area of the box. D enagide students, thickness of the box. Theta 1, temperature of one of the faces of this block. Theta 2, temperature of the other face. Q is the quantity of heat that has to be transferred from one phase to another. Now, let us analyze what are the factors on which the amount of heat transfer depends upon. So my first analysis is area of the box. If the area of the box is more amount of heat is transferred. Similarly, if the area of the box is small, the amount of heat transferred is also small. Therefore, I say Q is directly proportional to area. There is direct dependence of transfer of heat on the area. More is the area, more heat is transferred. Small is the area, small heat is transferred. Second one, dependence on temperature difference. If I want a small temperature difference between two phases, say by 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, if the temperature difference is small, quantity of heat transferred should also be small, alva. Kammi temperature difference ke kammi heat supply madre saku. But as in your furnaces, large temperature difference, 50 degrees Celsius, 100 degrees Celsius, 500 degrees Celsius, large heat has to be transferred. So Q is again directly proportional to temperature difference. What about the time of flow? T is nothing but time. Small interval of time, small amount of heat flows. Large interval of time, large amount of heat flows. 1 second, 2 second, 3 seconds ke heat flow kammi irutte. 1 hour, 2 hour, 3 hours takondre heat flow will be more. Therefore, Q is directly proportional to time. Now comes important thickness D. If the thickness of the material is more, opposition to the flow of heat is more. Buffalo skin antivi, emme charma resist martiyallappa anತಾರೆ. So as thickness increases, it will resist or it will oppose the flow of heat. Andre, as thickness increases, amount of heat flowing reduces. As thickness reduces, amount of heat flowing increases. Therefore, Q is inversely proportional to thickness. Now putting it in equation form, Q is directly proportional to area. Q directly proportional to temperature difference theta 2 minus theta 1. Q directly proportional to T, time of flow. Q inversely proportional to D, thickness. Now, how do I eliminate this proportionality? I introduce a constant called K, and this K is called coefficient of thermal conductivity, a number which describes the flow of heat, coefficient. Now I need to define this K, for which all other factors I make unitary. Area is 1 meter square. Theta 2 minus theta 1, temperature is 1 Kelvin. T, flow of heat is 1 second. Thickness is 1 meter. ಇದೆಲ್ಲ unitary conditions ಆಗೋಯ್ತು. Remaining Q is equal to K. So what is K? It is nothing but equal to Q. What is Q? Amount of heat which is flowing through a material of area 1 meter square and thickness 1 meter. For what time interval? 1 second. Why? To maintain a temperature difference of 1 Kelvin. So coefficient of thermal conductivity is equal to the quantity of heat flowing through a material of area 1 meter square, thickness 1 meter, for a time interval of 1 second to increase temperature by 1 Kelvin. And please note, its SI unit is watt per meter per Kelvin. So, in my today's session, students, I have discussed a critical analysis on conduction of heat. And we also have discussed thermal conductivity. When we come back in the next session, I will discuss about convection and radiation. Until then, thank you.